First, you cable up the test setup with the DUT, but you don't connect it to the DUT receiver input. You connect the DUT receiver input cable, the DUT that you're going, or the cable that you're going to take right to your, like your test board inputs, and you put it into a scope to calibrate the stresses. So you'll calibrate your RJ, calibrate your sinusoidal jitter, you calibrate your ISI. Then you'll select the test pattern, select the amplitude, add the jitter components, using scope to determine amplitude. This is the calibration step. While you're still plugged into the scope, you measure all of your stresses, your jitters, your amplitude impairments, your ISI. Then you take the cables from the scope, put them into your DUT receiver, and you turn on the DUT and the PG output, and you put your device in loopback, send those bits back into the BERT error detector, and you run the BER measurement for the desired confidence interval. So sounds simple. In practice, there's a few little details that are sometimes kind of tricky. So again, we have at least 5 high-speed digital AEs in Santa Clara alone, so give us a call if you need some help with getting this stuff set up. This is my summary slide, so we're almost done. Bit-error ratio is a primary measure of a receiver's performance. And the BERT is the tool, the primary tool that you use for characterizing them. We talked a bit about the fact that you can use an AWG depending on what your precise requirements are. Pattern generator and error detector are 2 main components of a BERT. We also talked about the fact that a lot of really high-speed DUTs might not have a loopback capability, so in that case, you might need to query an onboard error detector. We have ways to do that from within our BERT software. The PG doesn't put out a perfect signal. It adds calibrated impairments. We call them stresses to the data pattern. We talked about internal error checkers. We talked about the various stress types used to emulate the different impairments in the real operating environment. And careful calibration of those components is necessary for accurate and repeatable BER measurements. So virtually every compliance test standard calls out a particular methodology for using an oscilloscope to characterize the stress die prior to receiver test. And we have a lot of different receiver test automation packages that will control not only the BERT, but the scope through a calibration process and then through a test process. So if you've done this stuff manually, it takes time and there's a lot of data manipulation that you have to do, and our compliance test automation packages make that easy. That's it.